Thank you so much for inviting us, and really an honor to have a chance to present what we do in our university and research center. This doesn't represent all of us, just only for our research center. But next time when you visit us, Korea, we will have more chance. The title is the development of a hydrogen storage tank and distribution pipeline research and Hanyang Structures and Composite Lab. That's our lab. We call HSCL. I'm also the director and founder and CEO of KP.com. Actually, I'd like to introduce my two gentlemen. I will mainly cover the hydrogen storage tank. It's managed by the Dr. Sun.
Yeah.
And the hydrogen pipeline is by the Mr. Han.
Yeah.
They will get a PhD next month.
Congratulations.
Okay. Now, HSCL and 3P.com have been collaborating with the global composite industry. That's our background. And to innovate composite, there are three areas: materials, design, and manufacturing. So we always work with resin supplier and fiber supplier and apply to many different industries. And currently in materials and design and the manufacturing. So we've been working with Mark with supplying the thermoplastic material for last 10 years. And also Aditya Bora, Indian company who supply recyclable epoxy. And also Swamco is the Taiwan company which also supply recyclable epoxy. And those three companies are really supplying a recyclable resin system, which makes the composite recyclable, even for the thermoset. And Casey is the one who invests us about $50 million, $5 million, not 50. And then we just started the JV. And Shomarat and the Brazil, we do have some business. I mean, the collaboration in Brazil. Aeris is the one who makes all the wind turbine blade. And the aerospace-wise, DSO is a Singaporean research center. We've been working together, and Airbus and the Embraer is a Brazil aerospace company. We are the one who does the offset program. For the hydrogen, well, actually the riser, we've been working on the riser, sometimes with Petrobras in Brazil, and also work with Technip FMC in France. And the LS Cable, who is the part of our team, and also Ajista is India, and 3P.com is our company, and Hyundai. So bottom part to represent hydrogen tank, actually really applied to a current Nexo hydrogen car. It's not just the research, it's already commercialized. And upper part is mainly for the hydrogen pipeline. Well, speaking of hydrogen society, Korea and Netherlands has much common in terms of energy situations. We don't have much natural resource, so that's the reason we need to together move toward the hydrogen society. So basically, we can have a three category. One is the hydrogen productions, but unfortunately, that very important topic, but that's not our area. Our area is hydrogen distributions through a pipeline, and also hydrogen storage. Those are two areas, our research area. Okay, speaking of the our center, Hanyang supporting us in terms of a big space, I believe, 700 square meter in university, and with a 500 ceiling head. And we do have all kinds of manufacturing facility of composites, able to wind hydrogen tank and hydrogen pipeline, so we can demonstrate our design. and we can do a burst test, and we can do many things. And also, one of our specialty is to predict the fatigue life of composite. And then we have about the 12 fatigue machine, and whenever we design, we characterize the fatigue life behavior of the composite, and also some other test machines. Okay, this is the winding procedures of wet winding. So starting from actually the the fiber bobbins, and then through a resin system, and then we winding the tank here. We do here in our lab, we have a special resin mixing device and also UV curing, and we again very much specialized in design, manufacturing, and test facility. And again, this tank is not this small one, it's a big size, exactly same as the Nexo, it's a Hyundai car. As I mentioned, Aditya Bora, Indian company, and Swanco and Arkema, those are three companies. Currently, these are only three companies who can produce and supply the recyclable resin system. We are very lucky to work three of them at this point. So we developed the recyclable hydrogen tank for the Aditya Bora. We also developed hydrogen tank for Swanco and Arkema as well. Okay, well, this is the one, I hope okay. This is the, where we wind the tank and using the wet winding. As you can see, all the 9 camera. So we've been developing and winding more than 100 tank, but every time we monitor like that. And also, that was a wet winding, but this is the thermoplastic tail winding, which is the very much advanced technology. And we are using the, we call digital twin robot and simulations, and then the real winding procedures will be exactly same as the we planned. So whenever we update, whenever we do something, we start with a simulation of a robot winding. Speaking of the manufacturing procedure of a thermoplastic hydrogen tank, this is the very much of developed technology. We start with the liner, and again the digital twin system. This is a real winding procedures, as you can see that, and the operate by the robot system, and all the laser, which is just a heat, and usually after winding we put into oven, but in this case we don't need any oven, just the winding and laser is done. So we developed this one. I mean, all the procedures. I'm very proud of this product. And once we develop the hydrogen tank, as I said, we do the burst, perform the burst test up to 2,000 bar in our lab. Don't worry, it's very safe in the ground. Again, as I said, we already did about more than 100 burst tests. Even these days, almost every week, we wind and burst, we check the failure mode, and we improve the design, and depending on the fiber and depending on the resin system. Oops. Actually, this is supposed to burst. This is the camera inside of this burst chamber. So every time we do a test, we can see how it bursts. Okay, that was the first part of our research, hydrogen tank. Now the second part is the pipeline system we've been working on. As you know, the offshore, there's a composite oil and gas industry. This morning we are in the strong, very strong in the world. Mr. Mr. Bart is there. Thank you again. And here there are many different products, but again our specialty is the flexible riser, as you can see here. And speaking of this flexible riser, there are many different categories. One is the bonded, unbonded, and bonded, meaning that inside the structure is bonded is just a fully bonded, which was shown in the straw. But there is another one, unbonded. This is the slide between the layers so that it can deform more flexibly. And the upper right, it shows the strong offshore. The down, it shows the magma. Which product is better, strong or magma?
Easy question.
So this is all the typical pipe we can design. We don't produce yet, but we design all the products, including bonded and unbonded, and also hybrid and all kinds. And depending on the depths, depending on the, we will have outer pressure and inner pressure and materials, AS4, PEEK, and PVDF. And when we design, characterizations of material is the key. We need to have all the material property, which has to be input into a design tools. Okay, HyFlex is the tool we developed for last 10 years. Design tool for bonded and unbonded TCP developed by HSCL 3P.com. So we we can cover many different types of load, tension, internal pressure, outer pressure, and bending, and so on. And most importantly, we are able to predict the fatigue life. That's the most important, and buckling case and fatigue and creep. And it is based on the multi-scale based creep rupture and fatigue life. What does it mean, multi-scale? Well, multi-scale means that we have actually this is the all the fibers, for example, carbon fiber, and together with all the resin system impregnate. And with this model, we are able to predict a homogenized material property, and then we degrade material property on the fatigue, and we through a global analysis, we get all the macro stress. So all the combined procedures, and this program is again called HyFlex. Actually, the HyFlex, what does it mean? Well, first hydrogen, and second hybrid, and third Hanyang universe. So HyFlex is our name of the design tool. Okay, there are a little different versions. HyFlex 2, again, as I mentioned, static load is a internal pressure and bending, minimum bending ratio. Curved one, how can we predict the failure under certain curved radius, internal pressure, which is very important. And the fatigue is the this morning. Martin mentioned 30 years life, right? But can you imagine how can we predict 30 years lifelong? Is it not possible? So that's why we need a tool. It's called this kind of tool. We are able to predict the fatigue, guaranteed 30 years. So that's what the HyFlex 2 does. And who does use this HyFlex? Well, the Technique FMC is, for example, they are, I think, the competitor to Straw. Am I right?
Sorry?
Technique FMC.
Technically, yes, yeah.
You are competitor?
They are big like this, and we are small. We just
Anyhow,
started, yes. Yeah.
This is the one used by the Technique FMC.
Yeah. But we manufacture pipes for the similar applications.
Yes, a
Yeah.
similar application. And this is the one we do manufacture in our lab. And we mainly use the robot and also many different heat source. And all as a thermoplastic, you need a heat and pressure. That's the manufacturing procedures. We are using the HUM3, very special device, but we often use the laser source. And this is a glass and PE. Actually, this is the one we like to confirm the design and the burst test and bending radius. And again, to develop this pipe, we use all the simulations, digital twins. So all the this-axis and the robot 6 degrees of freedom and totally 8 degrees of freedom. We need to confirm very complicated combinations. And then we wind as a simulator here. And that's the, right now we are using the laser system. We could use different types, but this is a laser. Very effective, just the laser and it's done. In the strong this morning, the production is the heat outside, the heating device, but this is a laser device, just two different. I would say laser is a little bit more advanced. Okay.
It's different.
And as I said, all the technology we develop in university, now all the technology transferred to the 3P.com, it's a startup company, and then working with all the resin supplier and carbon fibers, and then all the, I would say, customers, and the China and the Korea, India, and Taiwan. I didn't say here the technique, but they are one of our big customer as well. And we also like to collaborate with the Strong. So main business area is the hydrogen tank and hydrogen pipeline. And the okay, well, we right now, my vision is to share our technology with the industry, so that we let's move together to the hydrogen society rather than just compete. That's our vision. Thank you so much.